Welcome to lesson 2 in the quadratic function section. In this one, we're going to look at all the ways that we can change the quadratic function so that the graph is slightly different each time. First, we're going to need to go through some definitions so that when we talk about manipulating the graph, it's very clear what I am referring to. So for orientation, that just means whether the parabola opens up or down. The axis of symmetry is an equation for the line that divides the parabola exactly in half. And don't worry too much right now if you're not totally sure what these mean, because we will be doing some examples with graphs for each, so it should become a lot more clear after that. The vertex is the high or low point of a graph. The maximum, okay, so we've got a maximum if a parabola looks something like this. So the maximum, we're going to say, is the y-coordinate when a parabola opens down. You could also be asked for the x-coordinate for a maximum. And a minimum is right there. So the minimum is when a parabola opens up. Domain is the set of possible x values covered by the function, by the parabola in our case, because all of our functions are parabolas. And the range is the set of possible y values. And that's it for the definitions. Okay, so going on to the next page, there's a couple different forms that an equation could be written in. We've got standard form that looks something like this. And then this form here is what we're going to be working with most of the time on this lesson. And that's called either vertex or general form. And the variables in this form, it's written as y equals a x minus p squared plus q. And we're going to be referring to a, p, and q a lot in this lesson and on the assignments. So in our case here, we've got a is equal to -2, p is equal to 1, and q is equal to 8. Notice that p in the equation is actually a negative p, so be really, really careful that you don't say in this case that p equals -1, because that negative sign is part of the equation. So p is actually the opposite as far as positive negative signs as you would think. So because it's x minus p, p is actually just the 1. And so moving on to some examples for orientation. So in this case here, for this formula, we have a equals 2, p equals 1, and q equals 8. And we have a parabola that opens up. On the second graph, we have a equals -2, p equals 1, and q equals 8. And this parabola opens down. So we can come up with a summary point here because we notice that the only difference between the two graphs is the value of a. So in summary, if a is greater than 0, so basically that just means if a is positive, then the parabola opens, opens up. If a is less than 0, meaning that a is negative, the parabola opens down. Okay, so another characteristic we're going to look at is expanding or compressing the graphs. And again, the only thing that's different in these equations is the value of a. In the first case, a equals negative 1/2. In the second case, a equals negative 1. And on the third graph, a equals negative 2. When we're looking at expansion and compression, we need to look at the absolute value of a, meaning that if a is negative, it's now positive. And if a was positive, it's still positive. So an absolute value just makes everything positive. So absolute value of a is 1/2. Absolute value of a is positive 1. Absolute value of a is positive 2. Okay, and so what happens with expansion and compression is that in this case here, looking at this graph, we say that this one is compressed vertically. This middle one is neither compressed or expanded. And this one is expanded vertically. And the way that I like to visualize this is that expanded vertically is like it's just being pulled down. So it's getting skinnier versus the first graph here where a is equal to negative 1/2. It's compressed because it's like the bottom is just being pushed up. So it's thicker. And in summary, the rule is that if the absolute value of a is less than 1, then it's compressed vertically. If the absolute value of a is greater than 1, then it's expanded vertically. Okay. And so now we need to look at the vertex. This is a really important part of the lesson, and I guarantee you that this will be a focus of the test and also of assignments. So it's really, really important that you can look at an equation and determine what the vertex coordinates are. So both the P and the Q. So we'll talk about that here. So this here is the vertex, and it has coordinates of 1, positive 1, positive 8. This vertex has coordinates of negative 1, positive 8. This one is 1, comma, negative 8. And this one is negative 1, negative 8. All right. So the vertex is equal to P and Q. So in the first one, remember for P, it's always the opposite of what the sign is in the brackets. So the P here is positive 1. The P here is negative 1. positive 1 there, and on the last one, negative 1. And the q-coordinate, most students get this right every time because the q-coordinate, the sign stays the same. So we have positive 8, positive 8, negative 8, and negative 8. So in our summary, I'm just going to put here to be careful. Because in the equation, so in the equation that we keep using, it's negative p. So you need to take the opposite sign, so positive versus negative, for the x vertex coordinate. Okay, so moving on to axis of symmetry. So the axis of symmetry in the definition is the line that divides the parabola right in half, so creates mirror image. So on this first parabola, that dotted line there is going to be what divides the parabola in half. And on the second one, oops, that's supposed to be a straight line. It's going to be that dotted line there. And the equation of this first line is going to be x equals 1, because all the way along that line, x is always 1. This dotted line, x equals negative 1. So the only summary rule we have to look at here is that for axis of symmetry, x equals p. And again, remember that it's negative p in the equation. So again, we have to remember to take the opposite sign. So for this first one, it's x minus 1 in the brackets. So the axis of symmetry is x equals positive 1. The second case, x plus 1 in the bracket. So it's x minus 1 for the axis of symmetry. Okay, now for domain and range. So again, domain was the set of possible x values. So in this case, the parabola, it just keeps on going. And so because it can just keep on going, eventually all x values could be covered because it just keeps spreading out to the right and to the left as it goes. So we write that in math terms as the domain is the set of x values such that x is an element of all real numbers. On your assignment, if you just write x is all real numbers in words, that's fine too. But sometimes it's nice to know what these symbols actually mean, because in future math courses, it could just be there without an explanation. So that's why I try to bring these into the course. And so I'll put this line here means such that. This symbol means is an element of, and this R is all real numbers. If there's ever a symbol that you see me give on your assignment feedback files or in the assignments or notes themselves and you don't know what it means, just ask me because I probably just forgot to give an explanation for it. And so that's domain in this first one, and our range is going to be equal to the set y such that y is greater than or equal to 8. Because if we look at this minimum point, it is 1 comma 8. And even as these continue to expand and move to the right and to the left and up, they will never be able to come back down and go lower than 8. So that minimum point defines the range. And in the second example, again, these two just keep on going. And so our domain again is all real numbers. And I'm fine if you write it out in words or how we did the first time. The range this time, we have a maximum at 1 comma 8. And so now our range is y is less than or equal to 8 because that maximum point defines the very uppermost point in the parabola. So it can never go above that because now everything's heading down. So in summary, the domain's really easy. So if we are considering the entire parabola, because sometimes the question might just be especially in word problems, just be talking about a certain portion of the domain. But if we're considering the entire parabola, x is all real numbers. And the range depends on the maximum or minimum. So if there is a minimum, then y is greater than or equal to q. And remember, q in both of these graphs is 8, positive 8. If there is a maximum, then y is less than or equal to q, because that maximum cannot be exceeded. Okay, so now we're just into examples. For coordinates of the vertex, okay, so let's take a look at this equation right here. So coordinates of the vertex, we're going to have positive 2, positive 5. The axis of symmetry is going to be x equals 2, and it is going to open up because our value for a is positive. Our domain is all real numbers. And our range, okay, so because this opens up, I'm just going to draw something here. That means that we have a minimum. So it's going to be y is greater than or equal to 5 because y can only go up from that minimum. Is it compressed, expanded, or neither? Well, this one, a, the absolute value of a is less than 1. So this one here is compressed. Example 2. Okay, so this one is just using algebra and our knowledge of the vertex form of an equation to solve. So write the equation of a parabola with vertex 3, 10, and y-intercept of 2. So we're going to start off with our vertex form. Okay, and we already know that this is P and this is Q because it's the vertex. So we can substitute those values in right away. X 3 squared plus 10. And the y-intercept of 2. Okay, so that's just telling us that when x is 0, y is 2. So again, we can substitute those in. So y is 2, x is 0, because we know that it passes through that point. And now we just use algebra. So 2 equals a, And this is negative 3 squared. So negative 3 times negative 3 is 9 plus 10. I'm going to subtract 10 from each side. Get negative 8 equals a times 9. And now to isolate a, I'm going to divide each side by 9. So I end up with a equal to negative 8 over 9. So I write my final equation of the parabola now. Y equals negative 8 over 9, x minus 3 squared plus 10. And that is it. Okay, one more similar to this. But now instead of an intercept point, they've just given us one other point that it passes through. That's fine, we'll just solve exactly the same way. Y equals a, x minus p squared plus q. Plug in the vertex coordinates. X, okay, so this is p, q, x minus negative 2 squared minus 3. So that's equal to x plus 2 squared minus 3. And now we put in the other point. So x is 1 and y is 6. 6 equals a. 1 plus 2 squared minus 3. Okay, and so that's going to be 3 squared, which is 9. I'm going to add 3 to each side. So I've got 9 equals a times 9. So if I divided both sides by 9 so that I could isolate a, I have a equals 1. And then to write out my formula for the equation, I have a is now 1, x plus 2, 2 squared minus 3. And we don't actually need to write the 1 there because it's implied if it's not written. So the best answer is that right there. If you left the 1, you would still get full marks. Okay, and here's just one little word problem. Okay, so we have some water jets spraying, and the path that the water travels is defined by f of x. And we have that x is the horizontal distance from the opening in the ground, and f of x is the height of the sprayed water. And remember that f of x is the same thing as y, so we're going to consider that when we look at this problem. So first thing to do on this is that you'll want to use either a graphing calculator or the Desmos free online calculator. For this course, you don't need to go out and buy an expensive graphing calculator. If you have one already, that's great. But everything that you need in this course can also be done using free online calculators. And for the final exam, you won't be allowed a graphing calculator. So you need to make sure that you have a non-graphing calculator for the tests. So if we open Desmos online graphing calculator and we type in our equation here, then our graph produced is this. So I'm going to draw your attention to a few points here, and that's 0, 0. And then we have our maximum, and we have our other coordinate. Okay, so I'm going to draw a rough sketch of this on our notes right here, and then we can look at answering these questions. So those points were passes through 0, 0, goes up to its maximum, which was at 12.5 and 18.75, and crosses the x-axis again at 25. Okay, and we are told that the x-axis represents the horizontal distance in feet, and the y-axis represents height. Okay, and the parabola represents the motion or displacement of the water. And so we need to answer what's the maximum height of the arc of the water. Well, the maximum height's going to be 18.75 feet, because remember that the y represents the height. So we're going to need to use our y coordinate of the maximum point. And now how far can the water reach? That's going to be our horizontal distance. So we're going to need to look at this right here, so 25 feet. And that's because our x-axis represents the horizontal distance. So we're going to take the greatest horizontal distance that x can be, which is 25, because this motion here, it keeps going, but it doesn't really make sense, this portion here, because 0 represents the height, which is the ground. So I guess if the water kept going down into a hole in the ground, then that's what would be represented by this portion. But really, that does not make sense in the context of the questions we're asked about this formula. So we're going to say that 18.75 is the max height and 25 feet is the max distance. Okay, so carry on and take a look at the checkpoint for this section and check your answers for these 3 questions with the answers provided on the Moodle homepage. And if once again, if you got them right, then carry on. If you didn't get them right and you're not sure what went wrong, please send me a message or an email.